We have a mini resistor DC circuit here, and our job is to get the power, current, and volts on all of the resistors present. So begin to analyze the circuit. The charge must flow through the 20 ohm resistor. When it reaches this juncture, it has a choice to go through these two or these two. So these sets of resistors must be parallel to these two. And then the current rejoins here on the way to ground must go through the 16 ohm resistor. So it looks like we have a series, and then we have a series of resistors in parallel to another set of series, and then back to another series resistor. Well, let's start off by getting an equivalent circuit here. So we are going to use the simplification technique this time. So we're just going to get 18 plus 51 here, and that gives us 69 ohms here, so I'll just write that as 69 here. Then 43 plus 91 is 134. So now we can think of these two as 134 and these two as 69. Okay, but they're parallel to each other. So let's get this total, and then we'll have a simple series circuit to simplify the rest. So let's get 1 over resistance equals 1 over 69 plus 1 over 134. And that resistance has a value of 45.5 ohms. Let's redraw the circuit. So we have 18 volts here. That goes to ground. Around here, there's a 20 ohm resistor, followed by our equivalent resistor, 45.5, and then the 16 ohms, and then this goes to ground. So let's put the 20 ohms right here, the 45.5 right here, and then the 16 ohms. Now this is a simplification of this entire circuit here. So then what we do is we can just add all these together to get resistance total for the whole circuit. So resistance total is then going to be 20 plus 45.5 plus 16. Okay, then the resistance total for the circuit is going to be 81.5 ohms. Now let's get the current total for the circuit, and that would be, so we have 18, so 18 volts equals I times R, so I times 81.5. And the current then, this is our current total, is then equal to 0.221 amps. Okay, now going back here, let me change colors here. So the amps going through all three of these resistors must then be 0.221. So we write that for all of them, so 0.221 amps. And this one here, of course, is 0.221 amps. This is a series circuit, so therefore they would all have the same amperage. So let's write this on top here then. This must be 0.221 amps. All of this is 0.221 amps. This one here is 0.221 amps. Okay, so our job to recognize then is there's 0.221 amps, okay, for this entire branch here. This is a series here in parallel. So we know then that the current total going through this branch here, okay, may be different than the current total going through this branch here. It'll be our job then to figure out, what the current is for each branch. Let's figure that out down here. Let's calculate the voltage on this. So I'm going to say the volts is equal to IR, so 0.221. I'll multiply that by 45.5, because again, we're using Ohm's law. The volts is going to be equal to 10.1 volts. So I'm going to write that on this resistor here. So 10.1 volts. And what that means is there must be 10.1 volts on this branch and 10.1 volts on this branch, because they're parallel to each other. So then I'll just write 10.1 volts. So I guess I'll write it here, and then I'll write it here. I know the volts then, and I have my resistance, I can calculate the current on each of the branches. So I guess I'll do it here. So I'll say 10.1 is equal to I times 69. And I'll write it down here. 10.1 equals I times 134. Okay, so the current on this branch here is going to equal 0.146 amps. And the current going through this branch here is going to equal 0.0754 amps. So now we have the current going through this resistor, going through this resistor here, and the current going through both of these resistors, because these are in series. That'll be the 0.146 amps. And then we know the current going through both of these resistors is 0.0754 amps. Okay, because those two are also in series. And that'll do it for part 1 of this video, and we'll do part 2 soon.